The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone. We are happy to have everyone here today, and for our viewers of today's panel discussion, we are excited to have everyone here to join us. And I'm also going to be joined by two subject matter experts and engineers in the industry, which I'll introduce here shortly. Everyone, my name is Joseph Ladner. I'm our Director of Engineering Performance Advisors here at Technical Toolboxes. And what we're going to be discussing here today is really having a panel discussion. And this panel discussion is going to provide an overview of 3 strategies engineering service providers, such as yourself, use to scale and win market share in today's climate. So let's kind of go through the agenda here today. Starting with 3 different areas or topics we're going to focus on. So again, my name is Joseph Ladner, and I'm going to be serving as your moderator for today's event. We're going to be discussing challenges engineering service providers face today on a week-to-week, month-to-month basis. The 3 most significant challenges center around really 3 different areas in regards to standardization within our industry and how that relates to your standard operating procedures, productivity of your organization, your teams, your groups, your engineers, your new hires, and your experienced engineers alike. And then we're going to be going into the risk, which we all know there is many, risk that engineers, managers, directors, vice presidents of engineering, and your C-suite face as service providers in the midstream energy organizations that you are in today. We're going to talk further about how successful engineering service providers, just as yourself, have met and not only done that, but bested those challenges, and what Technical Toolboxes does that has done so much to integrate digital solutions such as the Pipeline Hub and others into the engineering landscape. So again, this is really going to be an organic discussion going through these 3 different topics that you see here in standardization, productivity, and risk reduction. And you're going to get some great insight by our fellow subject matter experts, David Willoughby and Joe Pikas. With that being said, let's do an introduction. So we have our subject matter expert panel here today, and I'm going to do a little introduction to our first, and a name that probably is very well known by a lot of our listeners, and that's going to be Mr. David Willoughby. So David brings a wealth of experience within the industry, and that's a broad background that ranges over 40 years, where he has led and performed many different work and engineering projects alike, from the field to the office, that ranges from horizontal directional drilling projects, AC interference and corrosion. And he brings that knowledge and a lifetime of experience in pipeline design, as I mentioned, corrosion control and gas transmission to the conversation. What Mr. Willoughby does is he frequently shares his insights as a professional development instructor for Technical Toolboxes. I'm going to kind of go into that a little bit more here in our discussion today. But David has also authored 2 influential books on pipeline engineering, which you can simply actually look at on Amazon. One of them I've read from cover to cover myself twice, and that's on horizontal directional drilling. And they are phenomenal books that provides more insight and knowledge of not only engineering design, but also how that relates to the field. So we are excited and we are happy to have Mr. David Willoughby here today, and he's going to be speaking more here shortly. Next, a name that many of you probably know very well is Mr. Joe Pikas. Mr. Joe Pikas actually has more than 50 years of experience in pipeline engineering as an expert in pipeline engineering services, such as areas within risk, coatings, cathodic protection design, AC mitigation, and pipeline encroachments alike. Mr. Pikas has spent a considerable amount of time working for operators within our industry and also service providers alike. So Joe has a wide background, as does David Willoughby within our industry. Furthermore, in 2009, Joe received his NACE Distinguished Service Award, one of many accolades he's collected throughout his career. You've probably seen Joe Pikas speaking at different industry events such as NACE, or now known as AMPP, various conferences that he's participated in, really worldwide, but definitely here within North America. As a leading voice in the industry, Mr. Pikas has contributed to more than 50 papers to the industry from trade events, magazines, and conferences. So, Mr. Pikas, we are most definitely glad to have you join us today, and we're going to be hearing more from Joe here very soon. And last but not least, you have myself. Again, my name is Joseph Ladner. I am our Director of Engineering Performance Advisors here at Technical Toolboxes. I am an engineer by background, such as Mr. Pikas and Mr. Willoughby, and I lead our group of business developers, our training staff, our customer success team, and our sales team alike. And I cannot tell you how excited I am to be here today and accompanied by David Willoughby and Joe Pikas. As I mentioned, I graduated from Louisiana State University with extensive training in engineering, design, field experience, and have built my resume over the past decade, starting at Halliburton Energy Services, where I was a field engineer for a number of years. Then I started transitioning into more of the design and business development realm of life in the office. From there, I moved on into consulting and really started getting more ingrained in the pipeline engineering and midstream sector. And I've since joined Technical Toolboxes back in early 2020, where I have served various roles, and now serving the role as Director of Engineering Performance Advisors. So again, everyone, can't thank you enough for joining today, and I can't thank Mr. David Willoughby and Joe Pikas enough for joining us to share their insights in the industry, again, on the 3 different topics that we're going to be covering, which is standardization, productivity, and risk reduction. All right. So with that being said, let's move on to the first topic. So the first topic is going to be all about standardizing processes and calculations. This is a huge challenge that consistently faces not only the industry, but service providers alike. And what Mr. David Willoughby and Joe Pikas are going to do is kind of, based upon the topics that we're covering, they're going to share their insights into the industry in terms of what is the problem, and then they're going to go into further about what the solution is to that. And then I will be piggybacking from there on how the Pipeline Hub and Technical Toolboxes various software applications looks to address that. So let's look at the first challenge here, and this is where we're really going to dive into this into more detail with our subject matter experts. So as I mentioned, our first problem that we're talking about is inconsistent standardization and processes involving the various designs, models, and calculations engineers are running. So with that being said, I'm going to kick it over to our first subject matter expert, Mr. David Willoughby. David, so you see here clearly illustrated for you, a problem facing our industry is within non-standardized workflows, managing QA, QC. Of course, what goes along with that is repeatability, and then obviously delays and costly remediations dealing with lack of standardization. Could you kind of dive into that a little bit more, David, provide a little bit of your insight, your experience on what this is, and then obviously how you solve that problem there. So let's start with you, David, and then we'll switch it over to Joe.
Sure. Thank you, Joseph. Welcome, everyone, to the webinar. Glad to be here with you.
And yeah, I've like Joe mentioned, I have a lot of experience in the engineering sector. When I retired, I was the director of energy and corrosion at RK&K. I had about 50 engineers working for me in about 4 different offices. And when you have any staff at all, let alone the bigger the staff gets, the more widespread they get. One concern that we always have is making sure that we're all doing things first correctly, that we're doing them the right way, and two, that we're all going about our efforts in the same manner. And the engineer in Houston, Texas is going about the process, approaching it the same way that my engineer in Charlotte, North Carolina is approaching that. And a problem we had in the industry for years is that we wouldn't have that standardization. As a manager, it was very hard sometimes to get your arms around, why did it take engineer A an hour to do it, and it took engineer B 3 hours to do it? And a lot of time that would go back to the actual approach and how they were managing their workflow. So we had the problem, and we came, how can we best make sure that they're all following the same standard and they're all following the same workflow? And that was very critical to us, both in our time management, very important to us in our quality control. And you see the word there on the slide, repeatability. And that was one of the big keys that we would work for. If I had one engineer was designing the pressure, allowable pressure of a pipeline, and we're going through our QA/QC process, whoever's doing the QA/QC needs to be able to repeat that and make sure that we come up with the same answer. And again, that is one of the keys in our standardizing our processes, is to be able to have that repeatability. And sometimes you can get in a lot of trouble if you got one engineer doing it by hand, one engineer doing it in an Excel spreadsheet, one engineer doing it in MathCAD or something like that. So have a problem getting your hands around that, making sure everybody was kind of doing things the same way. And again, when we did that, when you have a problem with that repeatability, that'll usually result in delays. And if 2 engineers are doing the same thing and they come up with different solutions, of course, then you got to go back and say, okay, what is the reason that they got these different solutions? Who's right, who's wrong? Are both of them wrong? So those things causes problems, and again, can certainly affect the cost of what we're doing. So we're going to talk about the remedies later on, but that's one of the major problems that we have as an engineering provider is being able to have the key processes, and make sure the processes are being followed by all the different offices, all the different engineers, and that those processes, we can repeat them when we want to do our checks, and again, avoid those costly delays.
David,
you want to share something with us?
David, yeah, I appreciate that, and kind of go into that in a little more detail. Mr. Joe Pikas, would like to pass the mic over to you, sir, from a thought leadership standpoint. What, kind of looking at this and hearing what Mr. Willoughby said, can you share a little bit of your experience on, problems within standardization towards processes and calculations, and how you would look to, find a solution to that?
Absolutely, and thank you, everybody. What I want to do is take an ILI run, an inline inspection run, and see what some of the issues are and why standardization, such as the Technical Toolboxes hub, would be able to manage some of these issues. Example, you do an ILI run and you get your information back, where to dig and everything else, but there's other things that happen in between. Example, they went to run the ILI run and they had a small leak in the weld. Well, isn't that interesting? Not a big deal, but they were, how would you handle it and account for the releases? In the meantime, where they're out there, they found some exposed pipe in a river and then in a creek. So they had two areas of exposed pipe. And what about the water flowing around it and things of this nature? While they're doing their digs, their investigative digs, they found some issues with cracking, not just on the weld itself, but on the body of the pipe. So what do you do in a situation like that? So they're doing their metal loss calculations, and they have to be consistent. Are they using the same program? These are the kind of things that they need to be looking at. Well, the cracking issue is something, but they need to take care of that quickly. So are they going to get a crack tool, or are they going to do a hydro test? They're going to like to do a hydro test because of the age of the pipe. They would be better suited for that. And then lo and behold, they have to fix that issue with the leak. So now they're going to need a tool to determine the type of mitigation, and they're going to use a type B steel sleeve. Well, what kind of welding issues are they going to get into if they're going to be fixing that area? Another tool that they need, and be consistent. So this is one of the issues that to keep it standardized, but more importantly, like David said, they have to go across the company, because we have different groups that handle all these different issues, and they're not always in the same location. So from the field to the main office, and this is one of the issues. So what we want to bring out is we have the methods to have that standardization to handle all of these problems in a precise way, a standardized way that's repeatable, using standardized workflows. And we're going to talk about those workflows next. Thank you.
Mr. Pikas and Mr. Willoughby, I can't thank you enough. So, Joe, you've already kind of alluded to it, but I'm going to go to how technical toolboxes and our hub platform and the various applications within there help solve these challenges. Again, just to go back a slide here, to standardization, repeatability, and avoiding delays and costly remediations. So many of you have probably have heard of, or maybe even utilize our hub platform on a day-to-day, week-to-week basis. Many of you have not. Well, the Pipeline Hub platform is an integrated data environment that houses many different applications that Technical Toolboxes licenses, from Pipeline Toolbox that you know and love, from our corrosion bundled applications, crossings, integrated GIS, hydraulics, inspections, integrity, welding, you name it. What these applications do, are they are tried and true, industry known software apps that are going to create a consistent workflow for your organization. Mr. Pikas went through a phenomenal example of hydro testing, maybe some corrosion applications, and you're going to want to utilize something, obviously, that is known throughout the industry, that your peers utilize, but is also utilizing industry-known calculations and formulas that is always being adhered to up-to-date industry regulations and changes. Having a consistent practice as a director of engineering, vice president of engineering, that you know all of your engineers just within your group, whether if it's in a specific city or building, or maybe globally, is key. And that's what the Pipeline Hub is going to align things to. Second, it's going to create a centralized repository. A centralized repository, or what I mean by that is if you're running crossings analyses, horizontal directional drills, AC mitigation, interference, corrosion, you name it, it creates a centralized repository for your pipe data, your client's pipe data, reports that you are running, cases and analyses that your engineers are running as well. How you can do that in the hub is pretty simple. Via advanced report building capabilities, asset management, integrated GIS through Esri capabilities, and much, much more. And that also kind of piggybacks off of my final bullet point there, which is consistent reporting. So consistency is key, right? You don't want your engineering team out of the Gulf Coast to be doing things different than your engineering team in the Midwest, or even you don't want your senior engineer to be doing something different than your new engineer in training, your EIT that joined the company last week. So having a consistent way you are sending reports to your clients and also keeping in-house is key. And that's what the Pipeline Hub and the various applications that I mentioned earlier is going to do for your organization. So questions that we frequently get asked is, how do customers integrate the hub, which is of course short for the Pipeline Hub, into their standard operating procedures? Look, every organization is going to be a little bit different. It might center around IT and your IT security and how they implement it. It might be specific to crossings, API 1102, wheel load, track load. It might be as specific as that, but it's going to vary from organization to organization. But here's the beauty about the Pipeline Hub, ladies and gentlemen, is that it is flexible and has the capabilities to do whatever you need it to do, however you would like it to be implemented within your organization, whether if it's cloud, desktop, within your corrosion team only, or globally throughout every continent within the world. It is very easy to implement and do within your organization and how you want it to be integrated within your standard operating procedures. An example that I recently discussed with an operator on the West Coast of the United States is they actually have different procedures written out on different parts of Pipeline Toolbox, our crossings application suite, and our corrosion application suite, specifically RStream, horizontal directional drilling, and API 1102, and to where their engineers need to utilize those calculations and how. Well, they have that implemented in their processes, and then all their engineers have to do is go to a standardized suite. It's all there for him or her to utilize, and then they can go within the wiki site, which is our support site, on the background analyses and calculations that are being ran. All that is within their fingertips, which helps this particular organization create a consistent workflow for all their engineers. So that's just a little example of kind of piggybacking off David Willoughby and Joe Pikas on how our software solves these challenges for, again, standardization within processes and calculations. So with that being said, let's move on to our next topic, which is productivity. So productivity is a problem that's been ongoing since the beginning of time, right? I mean, that predates computers. But even in today's age, how can you maximize the productivity of your engineers while they're still positively affecting the bottom line of your organization could not be more paramount, right? So this is the next area that we're going to be diving into with Mr. David Willoughby and Mr. Joe Pikas. So kind of soak in this here for a second. So as far as increasing productivity of your team, your organization, and down to the individual contributor level, problems are going to range from decentralization of applications, duplication of efforts, right? Multiple people doing the same thing over and over, inaccessibility to your analyses, case histories, etc., and ineffective workflow. So let's kind of switch it up here, gentlemen. I'm going to pass it over to Mr. Joe Pikas. Joe, would you be able to lead us off here of problems that you have seen in your career on productivity of engineers? What that has looked like and kind of the solution to that, and all yours, Joe.
Okay, what I wanted to do is take off with those multiple areas of concern that propped up with the ILI run, and how important centralizing your activities. First of all, having multiple threats or issues occurring in a project is going to create chaos, okay? And you have a leak, you have exposed pipe, you have cracking that they found, and then the weld issues. All of these things are occurring all at the same time, yet they still have to do and get this get the information that they need, from the pig run and move forward. As Joseph indicated, what would be a perfect tool for a small leak? Well, it's called accidental release. They could calculate the amount of gas that's leaked, and then they could report that to the regulators, because that's important to know how much gas was released over a set of time. They got an exposed pipe in two locations. Well, one of them, they could do a bending calculation on the creek, okay, which is part of the tool system. And yet at the same time, they're increasing productivity. They don't have to go outside and get another contractor. They could easily make this decision, their decision themselves. The one in a river, let's take the one in a river, it's a little bit deeper. They may have to lower that in. And just lo and behold, they have a program. There's a program, a lowering program, where they could lower that in without doing a HDD. But let's just say they determine that, oh gosh, we may take care of it by lowering in, but look at the currents. What's going to happen long term? It's going to get exposed again, based on the flows. Then they can move to an HDD and come up with a cost estimate. This is a crossing program, which will allow them to do a very quick design and make an estimate while they're there. So they could begin to look long term. As far as the R-string calculations, they could do them rather quickly, and they're consistent because this program has been developed by PRCI. It's been around for a long time. And this is the nice thing about not worrying about the calculations or things of this nature. So as you could see, decisions could be made as they're going through their workflows. These are not ineffective, but very effective workflows, because they're addressing each one of these problems as they go down the line. And then with the weld issues, both on the pipe and on the weld itself, then again, they could make a decision. Yes, we could put a temporary type B sleeve, or make a cutout situation. So these are the kind of things that decisions could be made rather quickly, because these programs, as Joseph said, take into consideration the design, the operation, and maintenance, but more importantly, the integrity of the pipe itself. And this is important because having these tools will allow the engineer and engineers work in concert. Thank you.
Joe, thank you, sir, and really going into detail of the problems and it's how the various software applications that Technical Toolboxes solves that. Let's hand the mic over to David Willoughby now. David, able to expand upon productivity problems that within the industry throughout your career, and of course solutions to that you've seen, sir.
Sure, Joseph. I'm just going to let's talk a little bit about a drilled crossing. So let's say we've got a horizontal direction drilled crossing, and if we're looking at doing the engineering application for that crossing, that crossing, your procedure standardized, like we mentioned before. You don't have that standard way of doing things. You might have one engineer using one method of, for example, calculating pullback loads. He might be using a different method for calculating things like buoyancy control. And once he does those calculations, another calculation for borehole stability, he'll have a way he'll do that. And if that's not centralized, again, when it goes through the QA/QC process, the other engineer might be using some different applications, and a lot of times you wind up with a lack of that repeatability that I talked about earlier. And it was very common with our directional drill crossings, and because you'd have a lot of people that did their work in like a spreadsheet. You had other people do it in MathCAD, and again, just depending on how they built that application. And even the math formulas that they had to pull in to do the calculations with, depending on the reference you use, you might see a little bit of differences in how they apply those calculations. So it was very key that you got everybody using the same application and using the same data. And not only is that critical for our design and what we're doing in the design, but if you take a drill crossing, for example, the reason that the repeatability is so important, let's just say you do a design and you come up with a certain pull load and a certain bending stress on your pipe with that pull load. And you're out there and you go from design to operation, and all of a sudden they need to change the radius of curvature or something, and it's going to make a different stress load on that pipe. And one of the first things they'll ask the inspector or the designer is, can we do that? So having that data duplication, making sure we're all doing everything the same way is critical in being able to answer those questions out in the field. And one of the key things about the hub with the different crossing applications it has, we can calculate the pipeline pulling loads. It calculates the bending stresses. If we have to do buoyancy control, well, we can plug that right in there to it, and all of our stresses that we're going to have on that. And again, that allows us to manage those workflows and make sure the engineers, one, are working smartly, but two, they're working in a way that we can track and make sure that we're doing things the right way.
Thank you.
David, thank you, sir. I really do appreciate that. So moving on to how both gentlemen have already touched on it, various applications on the hub. Mr. Pikas went into some very good details there, and even individual modules and calculations within the hub that solve these challenges. But at the end of the day, the pipeline hub is going to solve these challenges in three overarching areas. One, it's one platform and one solution. I mentioned that on our couple slides ago, but you have one platform that your engineering team as a service provider is going to access to run full design, construction, operations, and integrity models, designs, and analyses on. So for example, your design team's going to get on there to run design and stress analyses. Your team that's running horizontal directional drills are going to utilize it for the HGD power tool. Your integrity team's going to be utilizing it for encroachment management, R-string, which is remaining strength of externally corroded pipe, AC mitigation, AC interference via your AC mitigation power tool, and much, much more. This is going to increase their productivity through automation, guys and gals. Leveraging your asset data in a way through GIS and automation is going to make their lives easier for data input, data sharing information, collaboration, etc. And this is all going to be streamlined through repeatability. So let me provide an example to that. How can we share this? How can we show and illustrate to you all heightened productivity? I'm going to piggyback off your example a little bit, Mr. David Willoughby. And we have a couple of engineering service providers that I could share to you, but I'm going to share one really cool. Anyone is interested. This is a crossings group. So they're utilizing our software for crossings, pipeline design. Particular group out of Texas, Louisiana, and Oklahoma previously had this various different groups, and they had different ways, kind of like how you mentioned earlier, David, and I'll even go back to this slide, decentralized applications. They had various groups across three different states of three different ways of how they did HGD design. So what they ultimately did is they had a problem, right? They needed to centralize and also have a standard way of how their different groups did horizontal directional drilling, design validation for pull force post installation calcs for both steel and plastic piping, and also how they did their inadvertent return analyses. Well, this all culminated to a really big project they were working on in the Tulsa, Oklahoma area for an operator in that particular region. And so what that group did is they utilized our crossing suite for a small part of a line replacement. It was about 1,000 feet. It was roughly about $80,000 worth of just project for them. They centralized how they did this design with our horizontal directional drilling power tool and various encroachment analyses. Project went phenomenally for them. They optimized their design. They finished the project on time. They were able to QA, QC their work, and ultimately their engineering directors felt good about how everything was done, sent those reports over to the operator, went very well. Well, this was one small part of a larger project, right? This was 1,000 feet of ultimately around a little bit over 18,000 feet of line replacement that mostly consisted of horizontal directional drills. So what did this particular service provider did is the operator opened up the rest of the project, roughly 17,000 feet worth of line replacement for bid. So again, if you recall, the beginning of this webinar was challenges that are facing the industry and how those challenges affect market share, or if you overcome those challenges, how you can increase your market share. This is exactly what this service provider did. So of course they opened up the project to bid, and the service provider sent some preliminary designs for bid, and they did the first 1,000 feet, right? So another 10,000 feet of the project was awarded to them. It went phenomenally. They were able to leverage the client's asset data that was provided over to them. They leveraged actually the knowledge of Mr. Joe Pikas and some of our SMEs that weren't even able to join today. They utilized the software. It streamlined how they did their process, and that remaining 10,000 feet of HDD line replacement went very well. And ultimately, I don't even believe it went out to bid. They gave the rest of the, I guess what would be 7,000 feet to this particular service provider. And what was once, as I mentioned, $80,000 worth of just a simple, very straightforward 1,000 feet of HDD, it opened up an additional 17,000 feet of line replacement and design that this service provider needed to do, which equated to additional $500,000 of work for this service provider. Again, it started off as 80,000. They streamlined their process and adopted the various crossings bundles, integrated into our hub platform, leveraged the GIS capabilities, and that opened up an additional $500,000 that they didn't have. You net that, that's $420,000. This client did not have, this service provider did not have with their operator. That opened up for them, and the job went very well. And to my knowledge, they're continuing to do work for this particular operator. Now, you got to have good engineers, right? This organization does, but you got to arm your engineers with appropriate tools. And that's what happened here through the integrated pipeline platform. Again, I'm happy to go through this in more detail, and we even have case studies on this exact case that I can share with you if interested. So with that being said, let's move on to our third and final topic today, everyone, and that's going to be risk reduction. You know, risk reduction is absolutely key in our industry. And for the third and final topic, we're going to go through how risk is key within your organization. And if that is not optimized, or if that's not reduced, you know, you're going to have a very hard time as a service provider within the industry on capitalizing on market share. So what are our SMEs going to dive into here? Well, first is the problem, right? You know, what equates to risk? Well, uncertainty in your engineering models, making simplified assumptions, difficulty verifying calculations, and then of course documenting those decisions and calculations for your customers in a reliable manner all equates to risk. So Mr. Willoughby, I'm going to go back to you to start things off here. I'm going to pass the mic over to you, and can, again, similar manner that we did to the other two topics, could you dive into more detail on the problem that you've seen in the industry in this area according to risk, and then how this has been resolved in your, in your tenure throughout the last 40 of years for you in the industry. Mr. Willoughby, I'm going to hand it over to you for you to dive into more detail.
Thank you, Joseph. I'll continue with the drilling concept. Just we talked about that. Again, there's many platforms that we can use, but drilling it illustrates these points real well. And and as any engineering provider, we always have to be very concerned about how we go about completing our engineering task. And we talk about uncertainty in engineering models. That comes back to our repeatability thing that we mentioned at the very beginning. So if I'm an engineer of record on a drill and I designed that drill, I've got to make sure that I can show what I did, I can show how I did it, I can show all my results, and that way I have that documented. That document becomes what we call the engineering record. And so if I'm designing a drill, and one of the problems again we would have in the past, what was that we had various models that we used, various methods the engineer used, and a lot of time, it would not track true the way that we want it to done. So what we tried to do was do something that we could verify, that we could verify those calculations, we could show how we did it, and we could show that record. So if I'm using the drill platform and the hub, I can repeat and I can show those calculations exactly how they were done, and I can show and document how we made those decisions. Give me a good example. Let's just say that you do a calculation for a pullback, and you come back with a certain pull load, and that pull load was more than you wanted. It real close to overstretching your pipe. So when that happens, you've got to make a decision as a drilling designer. What am I going to do to lower that pull load? You got a lot of options. You can change your bore path. You might change the wall thickness of the pipe. You might use buoyancy control. And the problem in the past is we have to go through multiple applications to see what we thought was the best solution. And the advantage of the tools now is that we can do every one of those calculations right there in the hub, and we can see which is the easiest, most cost-effective solution to approach. So if we do use buoyancy control, again, we've got that. We can verify that. That can be proven later on if somebody wants to know why did you do that particular method. It documents all of our decisions. It documents the calculations and how we came to those decisions. Very critical, not only during the final design, but in getting approvals from the owners, from the permitting agencies, so we can show them what we're doing. And a very, very big benefit on this right here, reducing the risk, is that we can go back and do a lot of alternative scenarios and not just get stuck on one scenario because it's maybe the easiest for us to evaluate. And again, we can do every one of those right there within that Power Hub. And we have good documentation. We have good visibility of all of our calculations. Excellent reporting modules right there in the program that we can print out a report and show what we're doing. And certainly, as a service provider, that certainly helps me manage my risk, helps me lower my risk. I'll never eliminate possibility of errors or omissions, but by doing it like this, I greatly reduce my chance of errors and omissions. Thank you.
Thank you so much, David. I appreciate your insight into that. Mr. Pikas, I'd like to pass the mic over to you, sir, and similar manner as we've been doing. Okay. Problems that you've seen in the industry on reducing risk and the solution. I'll hand it over to you, Joe.
Okay, I'm going to give a little bit of a twist on this. I'm going to break the risk into two parts. Okay, one part is on the pipeline itself, that already exists on the pipe. Example, time-dependent or threats like internal or external corrosion, SC, stress corrosion cracking. You got static and stable, which are the normal things that occur on the line. And then independent, time independent. In other words, unanticipated events such as incorrect operations, storms, ground movement, and things of this nature. We need to understand those first. Once we understand those, then we could begin to identify when we do some work on a pipeline, as David well pointed out, is identifying those events, where they're located, and how do we locate them. I want to bring in our GIS, ArcGIS mapping, our hierarchy, and more important, the data tools, because this is what it's all about, is the data itself, okay? And how do we manage that data? Because if we can't manage the data, then we can't understand the inherent risks that are already on the pipeline. And so this is one of the things that the technical toolbox hub does. It gives you that ability. I mentioned that ILI run. Well, now we know where the preponderance of corrosion occurred. We know where the leaks occurred, and the exposure to the pipe, through the water crossings. This is where the mapping comes in. This is where we could track the changes, and this is where the risk comes in. If we can't track those changes, then we can't reduce our risks. Just as David says, he's able to track his changes to reduce his risk. Well, we need to track it in a holistic way, not just looking, not just at one part of the pipeline, but in its entirety. And this is one of the things that is important. The hub allows you to do that tracking of the changes. This is how important it is. By tracking the changes, we could get the operational data or the design data or whatever data is out there or anything new that come in. And this is what we call continuous updating. Otherwise, we won't be able to know what's going on. In addition to that, we have a tool called ad hoc. Okay, what it does, it allows you to do a major search in these areas of concern. And this is important for any risk program to go on, how important this occurs. And so to get for continuous updating, this is the process that needs to continue all the time. So when we have these events that occur on the pipeline, and when we're doing our surveys, such as with inline inspection, or we're doing a dig, an investigative dig, or whether we're doing an HDD crossing, with its issues and soils and things, that we're learning each time, and this is why it's so important. So one of the things that we need to keep going is the ability to identify these events, these conditions, and those threats to the integrity of the pipeline. Thank you.
Joe Pikas, appreciate that, sir. And also kind of giving a little twist on it there. I appreciated that, and certainly resonates. So kind of going into how the hub mitigates and helps risk reduction here, ladies and gentlemen, is you're probably seeing a theme. Reliability, consistency via automation is really key to your engineer's success within a service provider. So how it does that is via consistent automated reporting. Within the Pipeline Hub platform across the various applications on the design end, corrosion, integrity, construction, you name it, you're going to have a consistent reporting process for all of your engineers alike. Whether it's the EIT that started yesterday and she's running just very simple design and stress calculations, or it's your senior trenchless technology expert that's running very, very complex compound bend angle designs with integrated two-dimensional cross-sectional overlay for cost reduction. There's going to be consistent reporting there as well. Also collaboration, ladies and gentlemen. Again, going back to it, the pipeline hub, i.e. the hub, is an integrated data environment. That means a lot of different things. That means a lot. But one area that really goes into is collaboration. Providing the ability for your engineers across your organization to easily share cases, share data, share reports to the engineer next door. Hey, we're in an environment today where, unfortunately, COVID, you know, the way the economy and the sector is, you know, we work from home. You might be in the same city, you might be next door, you might be next door to each other in a different building or the same office. But being able to share information quickly and reliably is key. The pipeline hub's going to do that for you in spades. And then also data integration. How you can leverage your client's asset data in a very security is key, right? But also a very reliable manner, so you can run your analyses, run your models, run your you know, ad hoc, run your analytics in a very quick, reliable manner is also very important for your organization to reduce risk. You don't want them to duplicate efforts. You don't want them to do things manually. You pay your engineers an engineering salary to affect the bottom line of your organization and to do engineering, right? So give them the tools to do that, allow them to integrate data is what the pipeline hub does. So it really goes into the final question there. It's specific features that enable these risk reduction capabilities. Well, across the many different applications, your engineers are armed with complex but also reliable calculations in AC interference via the AC mitigation power tool, integrated GIS within AC mitigation, hydro testing, horizontal directional drilling, investigative dig technology, to where they can leverage asset data to make very sound decisions that can ultimately reduce risk and also reduce cost. Automation as well. There's studies out there that says 90+% of in-house Excel spreadsheets contains at least one error. Again, 90% plus. You can simply Google it and look it up. Harvard Business Review has articles published about it. So unless you fall in that 10%, which most of you obviously do not, there is one error in your Excel spreadsheet. Where is it? Is it small or is it large? You might not know, but having a consistent platform that your peers in the industry utilize that's constantly updated to industry practices and standards, and also where errors are fixed and it's less prone to that, is key. Reducing risk within your organization is paramount, and the pipeline hub covers that in spades. So with that being said, let's quickly move on to different areas of our discussion today, and we're going to end this on a Q&A with our subject matter experts to close this out. So Technical Toolboxes helps companies and engineering service providers like yourself meet challenges through digital transformation. Digital transformation is here, ladies and gentlemen, and how that can reduce risk, reduce cost, accelerate project schedules, and improve profitability within your organization is key. How is it going to do that? It's going to be key in 3 different areas, and that's all going to be centered around how your organization leverages your client's asset data or your asset data through people, processes, and technology. And that's going to be through improving engineering processes through standardization, improving your engineering team collaboration, their efficiency, data disparity, and also the integrity of the data. That is huge within our industry, and having the right tools to do that is also key, which is what you see here on the next slide. So Technical Toolboxes is constantly looking for ways to help companies such as yourself meet these different areas. And that is what the Pipeline Hub is set up to do. Again, it's an integrated data environment that takes many different applications across the pipeline engineering sector, marries that together through one platform, one solution that is integrating GIS, integrating asset data, integrating a centralized repository to help and solve these different areas that you see on the screen here. Furthermore, how does it do this? Well, your organization, your data is going to align to your digital transformation journey. So what Technical Toolboxes has set up via the Pipeline Hub is we have bundled solutions. So whether you're within corrosion, you're in integrity, you're in crossings, you're in trenchless design, you're in hydraulics, heck, you're an API inspector within the downstream sector and you need a full API inspection suite. What the Pipeline Hub is set up for is to cater to your needs and help solve these challenges through an integrated platform, through subject matter expert support. You're talking with two of them today, David Willoughby and Joe Pikas, who you know very well. And then there's customer success, right? Onboarding, adoption, training within the software to make sure your people are trained to align to your processes. And then also back-end technical training as well, which you've probably attended many of those with David Willoughby and Joe Pikas alike. So what this is going to do is first is it's going to allow your people to have a standard automated way to conduct and produce complex calculations across design, construction, operations, and the integrity phases of pipeline engineering to a centralized repository. From there, it's going to align to your processes and take what was traditionally slow manual documentation or data entry, and it's going to improve data quality by leveraging work of others, reducing duplicated efforts, and increasing your engineers' productivity by 50 to 75%. And then lastly, it's all going to align to technology. It's going to take what was disconnected engineering tools and applications across your organization and integrate those via connected applications that your engineers are going to utilize daily, and take what was standardized applications and put it on a standardized platform that's going to allow for knowledge transfer, process standardization, workflow automation, and a collaborative environment. And all of that's seen here. There are various different suites across crossings, integrity, corrosion, welding, hydraulics, and inspections. Now, I'm not going to go through each of these in detail, but as you can see here, we have bundled suites that are all integrated on the Pipeline Hub that cover all of your various needs of pipeline engineering. If you have questions or would like to see these in more detail, we'd be more than happy to set up a discussion for you. And then last but not least, taking all of these bundles and aligning to people, processes, and technology, how this solves challenges for you in the industry, how the Pipeline Hub is going to help that, and the ultimate result. Reducing errors, streamlining your processes, which is through enhancing the productivity of your engineers by 50 to 75%, and therefore accelerating project schedules through enhanced technology. So in closing, everyone, we appreciate you all joining today. You know, what the Pipeline Hub is going to do is just that, which is standardize processes and calculations, increase your engineers' productivity and reduce risk. And ultimately, obviously, what's that going to do? Increase market share for you, which is paramount for engineering service providers in our industry. So as for next steps, look, we're having trainings all the time. You've probably attended some of those with Mr. David Willoughby, Joe Pikas. We have many other SMEs that conduct trainings in different areas of pipeline engineering, from in-service welding, vibration analyses, blastings, hydro testing, encroachments, external loading, you name it. Visit our website for that. If you would like to learn more about our offerings, we are happy to go through that as well, and how our different applications and different bundles can solve your challenges. Again, my name is Joseph Ladner. Please feel free to reach out to me. We'd be happy to do that as well. But here in closing, let's go to a little Q&A. So we have 5 questions here for our SMEs, and just over the next couple minutes, I'm going to read these questions out and have both Mr. Pikas and Mr. Willoughby provide their kind of thought leadership and answers to these. So going with David first. David, I have a question for you, sir, if you want to lead this off for us. You know, as a previous longtime engineering manager, how did you go about selecting the appropriate software solution that provided enhanced standardized workflows for your entire engineering team? That's a question for you, David. I'd be happy to repeat that if needed.
That's good, Joseph. I think that's a good question. The first thing that we would always do when we're going to select any software solution was reliability. We had to trust that the software was giving us accurate results. So when so if we're looking at selecting a software, normally we would take the software, we would run some applications in it, and then we would run our own calcs against it to make sure that the software is producing accurate results. You mentioned it a while ago very well. The software is a tool. It's not going to replace my engineer, but I want to give my engineers the best tools he can use. And if it's not reliable, then I don't have to go any farther. Well, once we determine that the software is reliable, the next thing we look at is ease of use. How easy is it for my engineers to get on board, to use it, to learn it, and to use it the way it's intended to be used. Some software platforms are pretty what we call user friendly. Some are quite arduous to try to use. So that would always go into our evaluation. And then another very important one is after we made sure that it was easy for an operator to use, was that we could, what kind of reputation did that software have in the industry? And I didn't really care that much if it didn't have a reputation, but I wanted to make sure it didn't have a bad reputation. So we would look at that pretty careful as well. And believe it or not, at the end of the day, cost was a factor, but it was usually the last thing we really considered was the cost. So primary thing was, is it reliable? Next thing is ease of use for my engineers, and is it a good acceptable tool in the industry?
Awesome. I appreciate that, David. Joe Pikas, let's go to you, sir. We have a question that's right in your wheelhouse. Can you provide an example of how the various corrosion solutions at Technical Toolboxes, either AC mitigation or R-string, unless there's another you'd like to talk about, Joe, provided you, Joe, yourself, or others with enhanced QA/QC and repeatability when running their models and calculations?
Okay. Thank you, Joseph. Well, first of all, let's talk about R-string. R-string was developed about 25, 30 years ago by Dr. John Kiefter. I just happened to be on the PRCI team in the development of the R-string software. And also I was on the team to do hydrostatic testing to prove up the software, the calculations and everything else. So I know how it works. I know the background behind it. And I'm very confident that the calculations have been tried and true for almost 30 years now. But more importantly, like David said earlier, it's the training behind it. We do offer, Technical Toolboxes does offer certifications for this. Since I was on the original committee, I offer certification that I teach them what not to do versus you could teach anybody the software in 5 to 10 minutes, but the rest of the day is spent on what not to do and all the pitfalls that could get you in trouble, not understanding metal loss and defects. Thank you.
Appreciate that, Joe. For the sake of time today, guys, I'm just going to go with 2 more questions, and it's going to go one to David and one to Joe. David, to you, sir, with your vast background in horizontal directional drilling, how can the proper HGD software application improve an engineer's or a team's productivity? And then possibly, could you provide an example of how Technical Toolbox's HGD power tool does this as well, David? Over to you.
It's one key way that any software with drilling software package would improve our productivity is once we go into a package and we build the base data, the pipeline diameter, the wall thickness, things of that nature, the size of the pipe, all the standard stuff, it's in there one time, and we don't have to go in and repeat that stuff. So as we do different calculations, like I mentioned earlier, an HGD is very rarely doing it one way and I'm done. It's usually going through an iterative process to see which way works the best. So productivity is really improved by not having to reload a bunch of the information that you already have in there. Another key thing that really helps the productivity of it is that as you try those different scenarios, again, you use the model that's already there, and you go into that model and you change one parameter or two parameters and rerun the calc that quick, and you see what the new data is. So if I did it with a certain size bin radius, and all of a sudden I get somebody ask me, can you, I need to go a little bit tighter on a bin, can you do that? Well, again, if I'm not using that package, I have to go through several steps to answer that question. If I'm using a good software package, I can go right back into that part of the software, change that radius, rerun my calcs, and give them the answer that quick. And the Power Tool does that. One of the key things that when I was the engineering manager, pretty much and I had design engineers, crossing design engineers in about 6 offices, and pretty much every one of them would use the even before the hub, the old crossing package, and we would kind of use that as our standard package, and that's the one we would use as our baseline, and then that really improved the productivity working from office to office, engineer to engineer.
David, I appreciate that. Joe, we're gonna round out with you, sir. Final question for you. Based on your experience within the industry as an operator and a service provider alike, doing software training and your background with technical toolboxes, which solution or which application provides the best ability? It might be more than one, Joe. They're curious on what is the best ability to accelerate project schedules and turnaround time.
That's a great question. And obviously, it may be multiple applications or multiple modules, as I just mentioned earlier in my presentation. So sometimes when we run into unanticipated events, we have that capability to make that change quickly, and this is what I like about the hub version, because they're all put together in an integrated fashion and standardized, and so regarding the specific application, it's going to be appropriate to the specific threat or conditions or design you're trying to do. Thank you.
Joe, I appreciate that, sir. Really do. All right, everyone, ladies and gentlemen, we appreciate everyone attending today, and those that will be viewing this in the future. Cannot thank you enough. So with that being said, we're going to go ahead and sign off. If you have any questions for myself, Joe Pikas, David Willoughby, please feel free to reach out. Go to our website, ping us via email. We'll probably upload this to our site. Reach out to us, call us in any way. We'll be happy to field your questions. So with that being said, we're going to go ahead and sign off, and thank you, everyone. Bye now.